All right, example 4, we're going to go ahead and take a look here. We got a slightly more complicated expression in that we've got subtraction now, not just a fraction, but we've got two fractions being subtracted. So first step is, as always, to just plug in. So here's where things get a little bit weirder, because when we plug in here, technically we get 1 over 0 minus 1 over 0, which is not one of the indeterminate forms. That's true. But if you think about what does the graph of 1 over t look like, so this first term here, what does the graph of that look like? Looks like this. So the limit here does not exist for this one term, okay? And no matter how you think about it, whether it's a left or right-hand limit, you're going to some form of infinity. So in the context of doing these form assessments, your initial plugging in to see what you get, if you get 1 over 0, you can just write infinity for the time being. And then here we get another infinity, because although this looks a little bit weird, we could graph it and get the same idea. But really, when it comes to this form assessment, anytime you have division by 0, you can just sort of relate this to infinity when you're doing these initial form assessments. So this I would classify as infinity minus infinity. So whenever you have something like this, or if you want to think of it as like 1 minus 0 over 1 minus 0, that's not technically one of the indeterminate forms listed, but in either case, you can go ahead and proceed in the following way. We want to go ahead and try to combine terms. So to do this, we can get a common denominator. Notice that this second term, it factors in the denominator to t times t plus 1. So we can just multiply this term by a t plus 1 over t plus 1, and then we'd have a common denominator. So let's go ahead and do that. We'll multiply that by t plus 1. And now that we have a common denominator, we can combine our two terms into a single fraction over t times t plus 1. The 1's cancel, and we just get t over t times t plus 1. The t's cancel, and again, we just have now the limit, as t goes to 0, of... Now remember, what happens to the numerator when you cancel? This might be worthwhile to rewrite. What you actually have is 1 over t plus 1. Canceling does not make this top go to 0. I see that a lot. That's not true. Right? If I have 4 and I divide it by 4, is that equal to 0? No. It's equal to 1 over 1. So in this case, we can evaluate the limit, and we will just get 1 over 1, which is 1.